Welcome back. We're part two of this video because the recording went a little bit long on the last one, and I hope everyone's got a fresh coffee to join us for this part two of this conversation about counterfeit parts.
Thank you. Let's go.
Across the thousands of individual components mounted on a contracted assembly line, direct oversight of the purchasing process disappears. Contract manufacturers operate under tight margin pressures. To cut costs, they or their sub-tier suppliers may substitute an approved component for a cheaper, unverified alternative, transferring immense liability back to the product owner. The strongest defense against this practice is deploying a consigned materials model. Under this model, the organization buys all high-risk and safety-critical components directly from authorized sources, then ships that inventory to the contract manufacturer.
Just wanted to jump in here to say, I think in the last several CMs that I've worked with or work for, it's been a pretty common practice to simply not substitute any components. So whichever manufacturer's part number is specified on the bill of material from a customer is the exact part that we would purchase. And whenever we have to go off of the approved distributors or normal distribution, we often are very transparent to the customer, the client, to say, hey, we can't find this part in normal distribution. We have found this part in a broker. However, we've worked with this broker. They've had a good solid history of proven a track record. Hence, they are on our AVL, our approved vendors list. This is why we suggest that you consider them. But ultimately, if there's liability, the liability does transfer back to the client to say, yes, you've approved us buying this part off of the standard franchise AVL. Any experience with that?
Well, first of all, I need to say I fundamentally disagree with what just has been stated by AI in this, that the only solution is that, you as an OEM keep the hand on the component, because this is why you outsource this to the EMS, because the knowledge and the networking and the ability to find the right component is exactly there. It's not with you, because where do I found it? Maybe something like Octopart, maybe I will go even to eBay or something like that and try to buy it. No, the knowledge, in my opinion, lies with the EMS, because they are the ones that are experienced with the materials. And this is where actually we should be pushing it for. And of course, the practice is you get the AVL at the very beginning, and then you are sourcing according to your AVL. You can do some changes, everything being approved with the OEM, but then it needs to lie with the EMS to source it, because this is where the knowledge and expertise is.
Yes, I absolutely agree with that take as well. And I also look at it in terms of the risk and the price to pay for the risk. For the OEM, if they make a mistake, let's just make another batch of the board. Too bad, we lost some money. But for a contract manufacturer, it's more than just losing that one build, the cost. It's also the potential reputation damage.
Yep.
Which is huge, because as a contract manufacturer, they have to make sure that they are a trusted source. And the moment that the trust is gone, it's a very, very bad thing for the business. So yeah, I think I would agree that this is not necessarily the AI suggesting a consign model. Yes, it's one way to do it, but really, as a contract manufacturer, we would have an open conversation with the client and say, hey, we're going off of the standard track to go and look for components through brokers. Do you approve of it? And we will take care of still working with the broker. Not to say that we're hiding a source, but we're just essentially revealing the risk. I think that's the main point here. So let's move on in the video here.
This entirely severs purchasing discretion from the assembly facility. For components where consignment isn't practical, strict right-to-audit clauses must be embedded into the contract. This grants the product owner the authority to conduct unannounced facility inspections to verify the actual source of incoming materials. Beyond external partners, organizations face a strict temporal risk, end-of-life component vulnerability. Products with long field lives, like medical devices or defense systems, inevitably outlive the manufacturing run of their internal components. This chart illustrates end-of-life vulnerability. When the manufacturer ceases production, legitimate supply drops to zero. Counterfeiters immediately flood the market with substitutes. To avoid this, supply chain teams utilize lifecycle management platforms. These tools track early warning indicators, flagging end-of-life notices years before the official discontinuation date.
I love this. I ever since I learned about Octopart and some of the other platforms, Silicon Experts, these platforms really are very helpful. And oftentimes I would go in my work with my clients to tell them, hey, you've got a last time buy warning, which is very, very helpful because it gives the client plenty of time to re-engineer a product, to design out the part that's about to go end of life so that they're not stuck in this potential threat of bringing a counterfeit part.
Yeah, I agree with you. I mean, the data is there. It's just a question of you as an EMS or OEM. How are you going to source it? Are you going to source it through the direct software like Z2 Data, like Silicon Experts, even CalcuQuote, because this information through IHS is already in there. And also distributors are sending you all of the information up front. It's question, well, how are you gathering this? So yeah, definitely, I agree with you. The visibility is there, and it's good to have the right source for that.
Yeah, on this particular chart, I'm just pointing out, going back to that point of last time buy, I just wanted to add, this is a very good strategy where the client, usually the OEM side, can work with the contract manufacturer to say, hey, can you buy an extra for 4 years worth of what I project in my usage and hold that stock for me in dry storage. This is something that it's tougher as an OEM to deal with because where you might not have a warehouse or proper storage facility,
Correct.
but as a contract manufacturer, we operated drying ovens, dry storage cabinets. This is one of the services we provide, and is a very good way to mitigate that risk because now you actually have the parts. Yes, there's a little bit of upfront investment, but more often than not, that part is maybe less than 5% of your bill of material costs. But it's the one part that potentially could become that golden screw. This is a great strategy here that the Notebook LM has come up with.
This lead time allows the organization to execute a last time buy directly from the authorized source, to warehouse the remaining inventory, or to initiate a form fit function redesign using modern equivalents. Outsourcing assembly and facing component obsolescence create deep structural blind spots. Securing them requires engineered contractual controls and predictive lifecycle data. Globally, the most common counterfeiting method begins in massive piles of discarded circuit boards. Unregulated e-waste recycling operations strip older chips off these scrapped boards, chemically clean them, sometimes alter their markings, and sell them back into the global supply chain as brand new inventory. Defeating this requires X-ray fluorescence spectroscopy, or XRF. Beaming energy into the component generates a spectral graph revealing its exact elemental makeup. If a supposedly new batch shows lead solder spikes on the graph, the part is recycled and fails inspection.
XRF. I love this. I've actually used one of these cool devices, and they're actually getting a lot more affordable nowadays than they started. I think one of the first XRF I worked with was probably about almost 15 years ago now. The machine was like tens of thousands, if not hundreds of thousands of dollars to run, and only the very exotic labs like an SGS would have one of these machines running. But nowadays with these XRF, especially like RoHS, they've become a lot more affordable. Like for a few $1,000s, companies can actually buy one of these scanning devices that uses XRF to look at the signature, the chemical signature of a component or anything actually, not just a component. So this is a very good way to ensure that the component doesn't have any problems. Looking at lead signature, as this chart points out, I think is an extremely easy way for whether it be an OEM or a contract manufacturer to screen for something that's obviously a problem. And of course, sending these parts out to a local test lab, they will often have XRF capability to scan that.
Yeah, I agree. I would just not really know where's the break-even point for buying that kind of machine as an EMS versus sending this to the lab. I understand in high lead times, I'm not even mentioning allocation times. Maybe the labs are overwhelmed, and this is where you can really win having that kind of machine. But
when an XRF, can be purchased for, I want to say under 5,000 US dollars. I mean, that's not a huge expenditure. If you're buying potentially parts that are $80 to $100 a piece, and you buy, 1,000 pieces of this, the payoff is pretty quick. But I mean, the XRF also isn't going to completely tell you if the problem is there or not, because as counterfeiters become more sophisticated, I talked about laser marking, and equally they might have ways to remove the lead and strip the lead chemically from these parts and then recoat them with lead-free solder, which it's plausible. I don't know. I'm not in the business of counterfeiting. I want to always think that my adversaries are smarter than I am. So to think a step ahead and to see what they could do and what they can invent, there's somebody is always more innovative out there and more creative when it comes to this, whether for good or for bad. Right? Let's continue here.
Another prevalent tactic is remarking. Counterfeiters alter the text on cheap commercial grade circuits, misrepresenting them as highly robust military grade components to capture massive price premiums. A highly effective defense here is solvent wipe testing. Wiping the package surface with acetone will dissolve fraudulent ink or altered markings, whereas genuine factory laser etching remains permanently intact. The verification difficulty scales up rapidly with fully cloned components. These are not recycled. They are manufactured from scratch on cheaper, inferior process nodes designed specifically to mimic genuine parts. Because they are built to function similarly under normal nominal conditions, standard bench testing completely misses them. Identifying a clone requires true parametric testing. By pushing the component to the extreme upper limits of its specified voltage and temperature thresholds, the inferior structural design of the clone is forced into failure.
I think this is where one of my clients that I mentioned earlier ran this issue. Maybe it was the part that failed only 20% of the time was one of these high quality clones. Maybe the batch just had some parts that were clearly not up to spec. Have you heard of a practice called binning?
Binning? No, what is that?
I learned about binning years ago working with a lighting industry client. In LEDs, not every LED is going to shine at the exact same brightness or wavelength. And the practice of binning has to do with the manufacturer testing each die individually and parametrically, as they call it, for the exact wavelength and the brightness at a specific input voltage and current. So then, the LEDs, even though they all come from the same silicon die, then once they get installed, some of them can be higher quality, brighter ones. Some of them are lower quality, cheaper ones, and they can still sell them different prices. This practice of binning has actually occurred for apparently many decades, because even in the early days when microprocessors started manufacturing, so companies like Intel, AMD, or others, when they make microprocessors, how we used to buy the super fast microprocessors that would run at, let's say, 3, 4, 5 gigahertz, whatever. And then you can get a cheaper version that only runs at 1.2 gigahertz. Well, that is the practice of binning by the microprocessor manufacturers. You can imagine that a higher bin product, you're going to normally pay more. But for somebody with nefarious intent and want to sell you and charge you as a customer the price for the premium model, but give you the substandard model, they're still the right thing, but it just won't work at the extreme. So this is what this chart is talking about.
This is why we have all those standards like PPAP for the automotive, because the components are actually the same, but you're grading them because they're going through much more sophisticated tests and they are passing those tests. And this is why you have to pay a little bit more for that component versus the other one. So yeah, I agree with you 100%.
Yeah, and we've talked about better, faster, cheaper many times in this podcast, and I still always abide by that. Is if something is cheaper, it's probably not better or faster. Caveat emptor, right? Buyer beware. We always were taught when we were young, and I think that's a good rule to stick to.
As counterfeit operations master surface level replication, visual inspection becomes entirely obsolete. Genuine verification has to penetrate the component's internal chemistry and absolute performance limits. The final and arguably most sophisticated threat vector moves beyond fraudulent parts and into deliberate sabotage, the hardware Trojan. A hardware Trojan is a malicious modification applied to an otherwise genuine part. The goal is to introduce a hidden backdoor, a side channel, or a dormant kill switch. This is frequently executed through compromised preloaded firmware. It acts as an invisible payload that no physical or chemical inspection process can detect. Protecting critical infrastructure from this requires mandatory DFARS compliance, sourcing strictly from certified trusted foundries, and executing all secure firmware provisioning in-house, so the organization controls the code entirely. But all of these technical mitigations share a single fatal dependency: the culture of the organization applying them.
So I know recent news about all the these AI chips and the U.S. government controlling them. I think this point that AI actually came up with was pretty interesting. I'd even thought about intentional backdoors in some of these more sophisticated parts. Do you think this is a real problem that we got to be careful of?
Well, fortunately, this has not really came across my path so far in the industry. We never know, and I think maybe probably one of the next topics we should talk is CRA, so the Cyber Resilience Act, and this will kind of and go nicely into this picture. And I don't really know if specific things that they really want to break the hardware maleficent here, but hard for me to say honestly.
I think so too. And I'm just thinking in terms of whether it be the EMS or an OEM for them to disclose that they have found a part with a back door. And first of
Yeah.
all, it would be very, very difficult to detect something like that. Second thing is, even if they were to find one or that potential back door or a Trojan load, to disclose something like that to in general media is also going to create a huge amount of geopolitical strain. And I'm not sure if this is something that is real, but the fact that Gemini came up with it and talked about it in this video kind of makes me a little worried. Like, should we be really worried about this? Anyways, let's hope that the world is going to be a better place for now and see go from there.
Quality engineer flags a suspect lot, but fears reprisal for halting a production line. The procedures fail. Leadership has to empower their teams to prioritize supply integrity over shipping schedules every single time. To support this vigilance, the industry utilizes AI-powered anomaly detection, scanning massive datasets, and cryptographic blockchain ledgers to establish absolute traceability. The line separating hardware procurement and cybersecurity has entirely dissolved. Total supply chain integrity now demands rigorous verification, backed by an uncompromising culture of zero trust.
And that's the end of this video. But what a wonderful way to to do research now with using these AI tools, which is very comprehensive to tell the story and kind of teach us. 'Cause I honestly didn't know about some of these aspects. I've heard bits and pieces of it, but never sort of putting it together. So, this AI video was actually a very educational and quick way for me to learn a lot about, counterfeit components and where the potential threat vectors would come from and ways of mitigating them.
Yeah, whenever the lead times go up, we go back into the counterfeit discussion. And as we are heading into this kind of time frame, again, as this is very cyclical, the industry we are in, then the topic will be live. Yeah.
Having worked in the electronics industry for many years, I mean, the cyclic allocation market problems will ever go away. Right now, we're in a very much of a memory crunch, as we already know. And some users of field effect transistors, the FETs, is still under a lot of high demand because of a lot of new green energy, power conversion applications that are in need for these kind of components. I don't think we'll ever get away from this. And I think this is probably one of the motivations for the nefarious, the bad actors in the market to create fake parts. But let's hope that we don't come across it in our lifetime for now. Touch wood.
Now, the good thing about it, if it's not going away, you can always prepare yourself. So as you were saying, you can invest a little bit into stocking, but there are also very good programs at the distributors with bond, for example, that they would keep those components for you, or you are tracking your legitimate sources before. Because the one other thing I find very strange is that broker is a bad word until allocation comes in. Then everybody loves brokers. Then they're buying like crazy. No one is really like, oh, this is not. And then, normal supply. And then they're like gone. But this is for brokers. It's also a good time to really show their muscles and their trust. So that people can really invest the time and work with them. And this is how I see the world changing. Yeah.
I'll just close by saying that, while, the broker name seems to carry some bad rep. I have worked with some very good, reputable brokers that were super helpful when push comes to shove. And I kudos out there to all the good brokers who are doing everything they can to keep the supply chain running when others can't. So yeah, keep up the great work, guys. So we're gonna wrap up here. Thank you very much, Arek. This is a fun conversation. Hope everyone who's watched and stayed with us until the end of the video here have learned something new about counterfeit parts and how to prevent them. So until the next one, drop us a comment and feedback as usual. We'll look forward to our next conversation.
Thank you, guys. Thank you, Ken. Bye-bye.
Bye-bye.